In this recording of a live coding session, I go over first an overview of the pitfalls you can have with snapshot tests, things to be careful of. And then we start doing TDD. And as part of test-driven development, it is very, very important to practice ruthless refactoring. That is refactoring more than probably most people do. Being really, really focused on those code smells. Let's do this. Welcome to another session of 90 minutes of live coding with me, John Reed. I am a iOS developer and a coach. You can find me here. I wrote this. And here we are with Mudshark, Marcus. Good to have you. Oh, and folks who are watching after the fact on YouTube, welcome. If you even start liking anything that you see, you know what to do. Give it a like. But I would also, likes are kind of, they're nice because they're easy, but I love it when people comment with questions, comments, even just encouragement, challenges, skepticism, whatever, random question. Since you're not part of the live chat here on Twitch, well, we can do an async chat via the comments in YouTube, right? So where are we? Last time, just to let's give some context. We're working on the Mastermind game. And we are, where is this? Let's, in our discovery tree. And if discovery trees are new, and pardon me for being pedantic, you old timers, and explaining stuff. I do that, for anyone who's new. Discovery tree is a way of visualizing work and making it visible and seeing like what's done in green, what is in progress in orange, what's to do, and various other things. And there's the parent work item, Mastermind. I'm just going to drag this over here so it's easier to see. Whoop, 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 like that. So Mastermind, the game of Mastermind works by making guesses. We have a secret code hidden under here. It's up to us, the code breaker, to come up with a guess and then hit the check button. That's what we want to work on today, is the check button. We get feedback. 1 right, 3, 1 right in the right position, 3 correct colors in the wrong position. So that's what we want to do. And so here we're working on feedback. The check guess button. We got the guess button tested with a snapshot. Let me review this for a second. The snapshot looks like this. And the reason we had to use a snapshot was because there was no way to get the disabled state through the environment, to set the environment, because we're in a sort of a simulated environment. Where'd my mouse go? Come on. Mouse pointer. Wow. Just got some heavy lag there for some reason. But there was a problem. Not a problem evident in running the tests locally, but it was a problem on the build server. This is a challenge with snapshots, and I'd like to talk about that before we get into today's code. Excuse me for a second. Snapshot tests check that you make a view and you turn it into a rendered image and that it looks like that, right? The problem is that snapshots are very, very touchy. They can break. Do you need to keep the artifacts? What artifacts, Mudshark? Other than these. I mean, they're in here, right? These are the artifacts. So they are checked in, if that's what you're asking. Yeah. No, the problem is that snapshot tests, because by default, they are checking exact pixel by pixel equality. They will change even slightly, even in ways our eyes can't perceive, based on what version of Xcode you're using, what operating system you're on, which simulator you're using, whether you're on an Intel machine or an M1, I mean Apple Silicon ARM machine, all these things. And so after we finished last session and I got the emails about how the build server was doing, and it was unhappy. Here's where we added the snapshot check button disabled. And even though it passed locally, it fails down here. And I was like, oh no. And this isn't something I wanted to do during the live stream because it's a lot of fiddly stuff. Yeah, it's got to be exactly the same. So I started adding some things to try to see if I could solve the problem. Let's see, this is all still last session. Here we go. I added some steps to list the architecture, get more info on the runner. You can see I tried switching. I'm using Xcode 16.2. I tried switching the runner to 16.2, but it crapped out, like it's not fully installed. So I had to go back to 16.1, various things. And finally, you see I'm green by lowering the snapshot precision. Let me just go to the latest one here. Oh, wait. Let's go here. Lower snapshot precision. First, let me show you. And this is a reason, to not have a ton of snapshots. Snapshots are very handy, but they come with a price. So I added some things in here to help with debugging. We get what version of Mac OS I'm on. That matches the architecture, ARM64. Yay, that was fine. The correct excuse me, the correct version of Xcode. Now I'm on 16.2, so I thought, is that the problem? So I downloaded 16.1 again and ran it locally, and the test passed. So there was no snapshot difference on my machine between 16.1 and 16.2. Remember having to ensure Swift 6 tool chains were enabled. Ooh. Huh. To run PuzzleKit unit tests on CI. So I did all this. None of this had an impact. And then I thought, okay, there is precision. We can say, maybe not make an exact match. And this is this the one where it started? Yeah, that's where I first went green. And I lowered the precision. And let me show you another thing to watch for. Holy crap. It took near 6.5 seconds, nearly 7 seconds. That's astonishing, considering that all these others run usually in milliseconds, which is what we want. Ooh, there's some slow ones in here. Ooh, there's some really slow ones in here. So I thought, okay, it's great that we're green, but slow tests is a real problem. The bigger your project gets, the more tests you have, the longer the test run takes. The longer the test run takes, the less often people will run the tests. Yep, upgrade, anything, it is super touchy. I'm used to putting in things to say, if you have snapshots, adding some scripts that prevent you from building unless it's like, let me check which version of Xcode you're on. Let me check that you're using the right simulator, all these things, so that you get quick feedback. I haven't set that up. Now, so 6 seconds here. I did improve that. I'll show you how. Let's go to the most recent. Most recent, also green. Come on. Wow, I think I need to reboot my machine or something. It's finicky. Not right now. Run tests. Get to the bottom where the Swift tests are. And look at this. Much, much better. Way better. A good factor of 10 better than 6-7 seconds. I did that by setting, there are 2 precision settings you can use with snapshot tests. One is precision, the other is called perceptual precision. Precision is basically how many, if we're assuming it's doing pixel by pixel comparison, how many pixels are allowed to mismatch. Perceptual precision means if 2 colors are really, really so close that our eyes can't tell the difference, let's call it a match. And that is more costly. It's more time consuming because it has to do the difference between colors perceptually. I know this from work I did at Adobe years ago. Is that human eyes are not computer eyes. We're weird, squishy things, and so we perceive different colors differently. We perceive some differences more than other differences. So perceptual precision, assuming this is how they've coded it, I haven't looked, isn't just, say, taking RGB values and doing math. It is saying, depending on the color hue, can we tell the difference? So setting it to 1, saying basically ignore it, did the trick. And so we can get rid of it now. And we actually have duplicate code here. I was going through and adjusting all 4 of these values, which is annoying. Let's do a little bit of refactoring. Let's just take that and call it as I don't know, pretty darn close. uh, close, pretty darn close is fairly expressive. So now we can replace the other one. And now I'm happy leaving it there. I'm happy, even though this is a default value, has a default value of 1. So we could not specify it. We could go like this. That should get us the same results. Now I'm going to run it locally. We won't know. It's going to pass because it passes if I set this to 1. Because it's a local comparison. But that seems like a good test refactoring. So that's stuff I wanted to share. It's important, if you use snapshots at all, to know that they come with a price. They can be very helpful, very, very handy, especially with UIKit. I've used snapshots as a way of doing, basically getting a local preview without having to run the whole app. I can just say, record this and just keep the recording on. Always keep updating the image, and then just keep it open and make a change. Like especially with auto layout, see how how does it look without having to run the app. Very handy in that front. Okay. Let's get back here. We now have a button. Let's run the app. We've got 2 colors and the check button, which does nothing, but it does enable. Does nothing. So let's make it do something. Let's make it do something useful. We really get the feedback on the button tap and show the feedback. These are really not separate things. What we want is to show the feedback on the guess. And to do that, we'll need to do some things. Well, let's fill this in as we go. So, show the feedback about the guess. And we are going to end up with 4 pegs here. These ones here are in the physical board. They're empty holes, and you fill them with white or black pegs. So they have 3 states. Empty, match, perfect match, and right color in wrong location. So I think in terms of TDDing this, let's come up with a plan. And you folks can just move off to the side. Give me room, give me space. So initially all 4 empty. That's a thing. We want to show perfect match. Not sure what the terms are. Let's have a look second. Mastermind game. Here's what it looked like. Key pegs. Colored red or black. Hang on, let me make this. Right, we don't have 4 guesses. Thank you. We have initially all it's all 2. Thank you. So we will have pegs per colors. Once placed, the code maker provides feedback by placing 0 to 4 key pegs in the small holes. A colored key peg is placed for each. Belongs in the solution but incorrectly positioned. Okay. So perfect match is not a bad term for that. Also want show initially both empty. I kind of want maybe another one that says how many there are. Another requirement. The size of the code determines the number of pegs. Yeah. So discovery tree is helping us visualize. This is also acting in a TDD way with what Kent Beck calls a test list. In test-driven development, you don't code multiple tests. You don't code all the tests at once. You code one at a time, but you do have an idea of what tests you're going to write. And that idea may shift and change, but he recommends write them down on paper. That is, not in code. Just scribble down or on a whiteboard. And scribble it down. So that's what we're doing here. And we can start working on this. Let's change this to in progress. Being a discovery tree, as we go, we may find other things that we need, but this is a good place to start. First, that we have a number of pegs Let's see. We don't have any idea of what pegs means or anything. It doesn't exist. We do have, if we come back to the domain code, we have the secret. So we can ask for the size of the secret. The guess here's the feedback. This is basically the feedback model. The number in the correct position, the number in the wrong position. And this is our evaluator that takes a guess and the secret and provides feedback. So with that, there's a difference between this, the feedback, and the number of pegs. Can't be worrying about diamonds when you haven't even tested that your region map builds. So there's a missing idea that is something that isn't expressed yet, and that is turning the feedback into pegs. I'm debating now which way to go. Do I start? And there's no correct answer here. It all depends. Do I start working on the pegs, or do I start working on the actual display and work backward to the pegs? The display, I feel like it might be helpful to create some notion of the pegs before starting. The validator, which validator, Marcus? The UI, basically my question is, do we test from the UI and go backwards, or do we create some notion of the feedback pegs, and work forwards? The code checker internally. Yeah, okay. Let's do that. So, working in the domain side. And by the way, there's no reason we can't, with the domain code, there's no reason for us to keep using XC test case anymore. So here we go. This is going to be, I'll call it feedback pegs. Oh, that's what you mean by debug descriptions. Oh, that could be very handy. Also, I love you, Mud Shark. Kisses. That's what it looks like. Kiss, kiss. All right. Let's make sure test 0 is hooked up. And now we can begin. With number of pegs is size of code. I'll just length of code. It really depends, Marcus. And one thing, I know you were out from this stream for some time, and one thing I've tried to do, much to Mudshark's annoyance, has been to try to drive this as much as possible from the UI backwards. Kind of an experiment. I think because I'm really used to laying out model stuff first, I wanted to feel what it felt like. And both are valuable, and a good TDDer can switch between both. The goal is to make progress, not to follow any particular style. So number of pegs is code length. Let's express this in comments, where we have, like, say, make a code of, and 4 is a good one. What's the witness? And there we go. Another handy tip I learned from Luell and Falco is write your tests as comments, and then in natural language. Write your tests as natural language and then turn that into code. Another tip, work backwards. I'll just back pegs. Count? Sure. The thing with expressing the assertion first is it avoids the trap. Taiji's the thing you've been working on as your personal project, isn't it? Expressing the assertion first forces you to say, how would I verify this? Even if it's not quite right yet, being able to put it in code. Otherwise, it's so easy for people to start like coding stuff up and then say, but I have no idea how to assert anything. Pegs. And this is not correct. I want to give it the secret. And now we can say, what do we got? Secret. How do we make a secret? Wow. I was expecting more. Okay, it's what's throwing me off, oddly enough, is that there was no explicit initializer. So it's a secret that takes a code with an array of code choices. I'll just call it secret. Secret. Interesting. It is picking up the stuff from my other project about creating nulls. This is not correct either. To make each code choice is, let's see, code choice 1 equals, there we go. Does the secret also hold the guesses? It does not. The game holds the guesses, I think. The secret stands alone. Let's see what we have here for... Oh, we do have a create null. Create null. That's for the secret maker. Eh. Let me poke around these other tests. Here we go. You know, 3 is pretty good. I just want a number that's different from 2. Like that. So if we do that, like that, this will not compile. But I think that is the test we want. Who validates? Well, we have a feedback evaluator that gives feedback, but we need to turn the feedback into pegs. So we'll get there. We'll get there. Let's do this. All right. So feedback pegs takes a secret. Let's make sure this is an actual type. Yes. Let's start now doing framing, enough framing to get this test to run and fail. So I create a new struct, feedback pegs, get rid of junk, and go back. So now it should say I have feedback pegs, but I have no way of making argument. Argument passed. Takes a secret. So let's give it an argument name, just for now, at least. And next one down here is the count. And we'll get it to fail. So now we should have a failing test that says 0 is not equal to 3. Or here, the expectation failed that we got of 0 is 3, and that's not valid. So let's be. So I'm using GitHub Copilot. I'm not using Apple stuff yet because I'm not on the latest OS yet. That may change now. So, quickest way to get this to pass. Let's follow very strict TDD. I like it as autocomplete. Autocomplete on steroids. I also like being able to ask it questions. That's not something that's revealed. For that, I use Cursor. So that test passes. It's obviously bogus, which means we need another test. Yeah, of course, it depends on company policy. Like the last client I had really leaned into it, and they were fine with the, you might say, the safety, corporate safety aspects of it. Environment, yeah, that's another question. I feel you. Let's check this in. So this is great. We made our first test. So this is in terms of lines of code. Hang on a second. It's not much yet. I'm not sure yet, Mudshark. We'll find out. So this is a small feature. Feedback pegs beginning with hard-coded count. By the way, let's check on the last test run. There it is. That's that extract step that I took early in this process. All right, so with test-driven development, we do the simplest thing that can possibly work, and that's to hard code it. Now we can look at refactoring. Do I want explicit initializers? I'll go without for now. We can change our mind on that. The test code is good for now, but we need another test. To do that, let's create the test for, well, we can make a test for 2. How about that? So I'm going to do a little bit of prefactoring by pulling these up and out. Hey, maybe we could do a parameterized test even. I don't think I've written a parameterized test in Swift testing yet. Move. Oh, decoding. Yeah, I can see that. Code choices into test fixture. So, to parameterize this, let's see what we can do. Where's my extract variable of any kind, Xcode? Come on. All right. Let expected count equals 3. And this is the secret code. Thank you for letting me extract that at least. Let's move those up and out. So there's our things that vary. You know, I should just run these tests. So that's extracting the parts that vary. Parameterized prefactoring, extract parts that vary. Now, I guess this now comes in as perhaps Xcode got confused by the hash sign before they expect. Oh. Or because it is in a macro. Yeah, that could be. Because all this expands into gobbledygook. Ah, that's a great guess, Mudshark. All right, let's see. We've got secret code. That is a code choice, and the expected count. That is an integer. And now, how do we do this? It's offering a suggestion. One collection, all combinations of two collections. I want to see both ways. Arguments. Do. Or what's this other one? Wait. Swift testing does combination tests? This is news to me. I was unaware of this. I thought the tool I made, approval tests, was basically the only thing out there for combination tests. Now, I imagine mine is still easier, but let's go with one thing at a time. So if we say red, green, blue, 3, will this You know, tuples are okay to get started with. I mean, this is a tuple. but of course it's not working yet. Let's go back. Yeah, it's an array of tuples, of which the first, they match up per argument, and I thought I had that in here. Well, let's look it up. Arguments. Maybe it needs. Maybe it can't use these. Oh, that okay. This is my theory: is that it can't use. It can't do this because it can't access these instance variables. There we go. So let's move it out. Oh, thank you. I will check this out after the show. Thank you for sharing that. So if we move it out, there it is. Okay, so that's a learning, is that they need to be they can't be use things inside of the fixture as instance variables. It's got to be out here. So now I should be able to delete these. And that should be a pure test refactoring that is happy. Yeah, private. I mean, it just had to get outside of the test structure, unfortunately. All right, so that is many of one. Many of one is another trick from Luella and Falco, that to go from one thing that was our hard-coded inputs into a list of things, or a collection of many things, there's an in-between step, and that is to create many of one. And that's what we've done here. So now we can break our test by adding another tuple. I'll just add it up front and say red and green. 2, and let's see what this failure looks like. This will be my first time, like I said, running, creating a parameterized test inside of Swift testing. And there we go. That looks nice. Feedback pegs count 3, expected 2. And what does it show for the test run itself? This is one of the things that I find a little annoying about Xcode, is the need to sort of poke around in different ways to see it. And here we can see the arguments, and that the results for those arguments don't match. All that, it's like, why didn't you show that to me before? I was looking at the code, wasn't I? If you tap show, you should be able to see this information without going into the navigator to do it. Let's try that. And where would I see? Ah, thank you. That is much easier. Thanks, Marcus. Great. I'm learning. I want to put that down right away. Tap show on parameterized test failure for details. Nice. Okay. So we have our failing test. That brings us back here where we can now say this should be, I'm a little leery of having this exposed. And I saw a trick in Walmart code that I might start using for basically keeping things private, but creating like a test only, I forget what it was called, like an access point. Test hooks, that's it. Let's start this way. And I don't like it. But let's get to green. All right. Yeah, we'll find out. So this is getting the what do we want to say? Yeah, I don't like this. I don't like poking into the secret. I think this should be none of our business. I'd rather have a count exposed here or a secret size. I kind of like that. Instead of just count. Let's do that. Basically, I want to take this and do a move. This is a code smell called. What's the right word? Insider trading. It is also a violation of yeah, the law of Demeter is a great clue that we have multiple dots. So let's do a quick and easy. Train wreck is another good way. Secret size, I like it. Paste and fix up to be local. So now I should just be able to get the secret size. So we're doing refactoring to improve the code, but it's helpful to do that from a place where the tests, refactoring it works best when you have passing tests and you go from green to green without going through red. Refactor, and I gotta say, I like not having had to make another test and come up with a name. It would have been number of pegs is code length 2 and number of pegs is code length 3, right? Is how I would have written it with non-parameterized tests. So hooray, my first parameterized test. I learned some good stuff. Let me jot these down. Yeah, secret.secret is kind of funny. um, so the parameterized tests arguments can't use classical fixtures. So we have to move them out. Hey, there are more folks watching. Welcome. Glad to have you. Follow me for more. Like, hit that, whatever it is on Twitch, the follow button. So, now you may say, this is an awful lot of work for, like, no code, secret size. Let's do a rename on that. You may say it's an awful lot of work. The thing is, with test-driven development, it's not just about code stuff up. It is about, and it's not just about writing tests. It's about the process of introspecting, going through the 4 steps if you count pushing to main, or integration, that we always want to be cleaning, looking for code smells like this. Secret. Let's rename this. Could be count, but I kind of like size. And everything should still pass. And push. All right. With that, by the way, I'm curious, what is using code? And if we can't do test hooks, if I change this to private, yes, exactly. I don't want count because, like, what that sort of betrays that it's an array. It's like, none of your business. So this initializer should now make it happy, but I bet there's a test. Let's see what breaks by doing this. And that's not a test. Ooh. It is another violation of the law of Demeter, another code smell of insider trading, or you might say none of your beeswax. The way I express the law of Demeter, the law says basically you can ask things, you can send messages to things, but you shouldn't send messages to a thing and then send a message to the thing that you got from back the thing. I say you can pick your friends. That's secret. You can pick your nose. That's your internals. But you can't pick your friend's nose. This is crying out for something, an enumerated sequence. Enumerated code might be a good way to put it. Or we pass the index and the secret TMI. I'm squirming a little bit, wondering who should do this. Indexed code. Like, is it giving away too much, or does the feedback evaluator sort of belong in the code itself, or the secret? Who should talk to who? Let's spend a little time on this, because I don't want to rush. I want to make sure that things are actually object-oriented. And this feels funny. Like, is the feedback evaluator actually part of the secret? I'm not sure. Well, let's start simple. Enumerated sequence of... Yeah, it's kind of... I don't like returning that. But let's start there. Don't overthink it, John. Yeah. I don't like returning the enumerated sequence of here's the array of code choices. That just feels like it's exposing this all over again. Let's move it. Get reset hard. Try again. I'm starting to think that the feedback evaluator is in the wrong place. It takes secret. It uses secret. It takes a guess. Let's have the secret evaluate the guess. So let's do a move function. Get up. Although I think I've got a good guess. Move function. Figure out how to reference the target function from the source context. Okay, we're going to take this in small steps. So I'm going to start by keeping the feedback evaluator there and having it delegate to the secret. Copy the function to the target context, adjust it to fit its new home. I'm going to take this, copy, paste. Oh, and matches might just go away here. Paste this up, and so we get rid of that. No, matches. Interesting. We have feedback and we have a match. That smells funny too. All right, having pasted it in and fixed it up, it should build. Figure out how to reference the target, turn the source function into a delegating function. Here we go. And now I can say secret evaluate the guess. Get rid of all this. And all our tests should still pass. Let's do this. Hello, keyboard. Thank you. Hello, computer. So this is move function on of there we go. Now we have a lazy object. Lazy element. And the thing we want to do, so I'm looking up in the book, which I thoughtfully kept right here and without, so that I didn't have to go run back to my bookshelf to get it. I look up the code smell lazy. I see lazy element. The refactorings for that inline function. This isn't a function. Inline class. That's what we want. The feedback evaluator needs to disappear. However, I think the only place it's called is from tests. Yes. So we can maybe move the tests onto the secret. Let's see what we have for secret tests. We've got we'll find out. Let's copy all. Oh, wait. This is feedback tests. No, this is not feedback evaluator tests, although it is kind of. These are feedback tests. I might keep them here. It's a little confusing, but let's rename this first. The evaluator becomes, oh, evaluate is right there. So I ought to be able to say, don't make the feedback evaluator, make the secret. Like that should still pass. Woo. Same. Same. Now nothing is using feedback evaluator. It is dead code. Let me check this in first. Yes, it would. Thank you, Andy. And it's also kind of funny that this is feedback, but the SUT was feedback evaluator. Yeah. Great observation there. You picked up on a good like repetition, which thankfully was only 3 tests. You so with that, feedback evaluator is dead. And we run tests. Actually, just building ought to be enough. So this is, I would say, in terms of the safety of this change, it's not automated. Maybe I'll update this description. It is something that only required a build. So super low risk, delete dead feedback evaluator. So this is cool because this is not where I thought this test would go. Yes, let's do that right now. Secret. Private func make CT. That takes it would be nicer if I didn't have to keep distinguishing. Like these code values aren't actually important. The colors themselves aren't important either. All I'm doing is making distinct code choices. And I'm doing this over and over again, and it's getting tiresome, isn't it? But this would have been nicer to do. Would have been, Andy is totally correct. Rather than fixing this up, and this would become obvious if there were like a dozen tests rather than just 3, to basically make the helper you know what? I'm going to give it an explicit name after all. It would have been easier if I made the helper first. Let's test this one. Whoops. That's why I test it. Okay, so make SUT there, and that should do it. And the evaluator now, let me just piggyback this real fast. Yep. I'm with ya. And now the feedback tests might be in the wrong place, but this is all a whole lot better. Let's examine what we did. So this is mainly extracting that. Coolio. We are getting better. The feedback tests right now are in Swift testing. The secret tests are old because this project is old. You don't see the win. In which coder tricks? The make SUT because it's so small. The thing that changed, and this is totally debatable. Like maybe this is okay. So where this would have helped is originally this was not calling secret. This was calling something else. This was creating a feedback evaluator and passing the secret into it. And it changed in across 3 tests. It would have been nicer to extract the make SUT first and then make the change in one place. I admit, it does look unusual to my eye, but I'm starting to learn that make SUT, having that in a test suite is valuable, and I should consider doing that everywhere. Like I think we already started doing that in some places. Oh, we called it something else. Make guess, make game, make code choices. Kind of want to rename those to all be like, what's the thing that makes the system under test? Make guess is different. That's not the system under test. But make game. And here we can see something more complex than just passing in one lazy thing. Let's make this, consistency isn't necessarily the name of the game. Sometimes it can be silly to chase consistency, but by making it the same name, the pattern becomes clear. Rename. That's one. Let's do this and then we'll wrap it up. Next. Ooh, yeah. Here, thankfully, they were all named SUT to begin with. And two more. Ooh, this one's different. The SUT is over here. This is a different thing, so we'll leave that alone. And here. Also different. Okay. All right. That is a wrap on this session. We can mark this as done. We will continue. The great thing about a discovery tree is it makes it easy to tell what's going on. Hang on. So this one, make game. Oh. Oh, yes. Oh, you're right. We make a game and then make the SUT. Let's sneak it in. Because Andy says, we are doing this everywhere. Thank you, sir. So let's extract. I'm not going to do this automated. So this is SUT, which is the game screen. And then we return that. So if that builds, which it should, that will simplify these considerably. Here we go. Oh, no. Look. This is why they're separate. I need to reference the game. I need to make the game and then pass it in. Okay. Gonna scratch that. It was... How often... Yep. Not everywhere? No, there are places. Yeah, I'm gonna scratch that. Great to try it, though. Great to try it. All right. Back here, let's do our retro. What did we learn? What did we observe? Pretty sure that can we make helpers less specific, more tolerant of change? I'm just looking to see if I already had this in the notes. All right, so we've got our first parameterized test. Arguments can't use member variables. Tapping show on the failure. Great thing to learn. Use that more. And code smells. Oh, we got rid of a lazy object by recognizing that like the responsibility was misplaced. So really, and this is the kind of thing that's easy to miss if you're not doing TDD and asking yourself what can be cleaner. That doesn't mean you have to do TDD, of course, to find and fix code smells, but it's part of TDD. It's usually not part of coding methodologies outside of TDD, or practices, I should say, not methodologies. The way people actually code. It is definitely safer, but it's also just part of the checkpoint of going around to say, we got a failing test, great. We got it to pass, great. What do we clean? Keep looking at cleaning up the code. What's curious is that this messy code is stuff I made. And so that happens. It's okay to change your mind. But follow and refactor ruthlessly. Yeah. It's a very good habit. All right. Then that's it for today. Thanks for coming. Folks who are watching on YouTube, thanks you for watching the whole darn thing. Hope you enjoyed it. Give it a like and add a comment. That would be fun for me. Just more than just seeing a number increment. It's fun to hear directly from people. Thanks everyone for participating, and I will see you again next week. Then we'll keep going with the feedback pegs. All right, take care. Bye-bye.